All right, I'm going to show myself, even though there's only Jasmine with me now. We're going to talk about chapter 7. So today we will discuss the two-dimensional array, which is actually a matrix. This can be extended to multiple dimension. It could be, three-dimensional, fourth dimension. But normally in your study, the maximum probably is just the three dimension. Um, we use two dimension to show you the ability of the MATLAB to handle different size of matrix, but you can also extend that to higher than two dimensions. So we're going to look at that. And I'm also going to not only do some demo, but I was also like to tell you some of the challenging problem that you're going to finish in this chapter, which is not easy. So um, that that will help you to finish those labs. Those are not easy if you are the first time coder. Um, so I'm going to give you some hint about that. So let me first switch the screen to uh, the Zybook. Okay, we talked about the 1D array last time. We also show you some application, the application including that you can play some of the music, and you can also use some of the function to find the uh, the rounding of the numbers. And also we talk about the sum, talk about the complex number. Those are very useful function. Um, there's so many function in the MATLAB. So sometimes you might see some function that I never used before. And if you do, then you can share with us. Then we all learn with each other because they're just adding more and more functions to make it useful. And that's the reason why people wanted to use MATLAB, because for engineering, we're not like a professional coder. We actually just try to use the computer to help us to do our job. So the easiest way for us to use that will be the best tool for us. And the MATLAB actually has hundreds and thousands of people using it, and they develop a different kind of a function for us to use. So if you know some of the function, you can just get it and you can just use it. Our focus for today is two-dimensional array, and we'll start with the basic. And the next time we're going to talk about more advanced stuff. Then we'll give you some other command that you can manipulate the metrics into different way. And after that, the next thing on the next week is we're going to talk about data visualization. This is the part that I love the most, which is the plot. So I'm going to show you several different ways that you can present your data with a plot function. And there's an additional to the plot, they also have three-dimensional graphic representation for the data as well. So I'm going to show you some of them. And after next week, which is 2 weeks from now, you're going to have the first exam. So I will give you a practice one so you can take a look what the exam looks like next week. Then after the first exam, I will start to introduce the project, and then we will move on to the next topic. Okay, so let's look at the two-dimensional array, which is chapter 7. Okay, so first part, let me see, 7.1, okay. The first part of this is simply just tell you how can you create a two-dimensional array. Now, again, this idea, you can extend it to three-dimensional or even more. But more commonly is that you have to know how to create a two-dimensional, which is just a matrix. And there's several different ways. And the most important thing to create a 2D array is that you use a symbol, which is the semicolon. So I'm going to use the demo to show you some of the way to create an array. and how can you use those symbols to create an array. So let me change this one to my MATLAB. The array and use some examples. And so when you are looking at a one-dimensional array, that we have a common, right? You can use a common to represent the separation of the element. You can also use space instead of using a common. So they simply represent the same thing. A space and the common is the symbol to separate two different elements in an array. But if you wanted to create a matrix, that means you have several array or several columns, then how can you create that? Well, you use semicolon. So this semicolon symbol is the symbol that you can create a different row. So semicolon is that you change the row to the next line. I give an example here where I start with an A. A is a variable. I make the A equal to some elements with a bracket. So the square bracket is the symbol that you enclose whatever the element in an array or in a matrix. By the way, array is just a special case of a matrix. So in general, all the array is also a matrix as a part of the matrix. So if you understand about the matrix, then you can apply those to the array as well. Now you notice that I specify A equal to 1, 2, 3. Then I put semicolon 2 and 3 and 4. So that the common in here simply just separate element in a row. And the semicolon here represent you're going to change row. So if you run this, which will give you actually a 2 by 3 matrix. And if you have this matrix, and then you can do several things to get a subset of the matrix. So let me just run this one first to show you what the result is. So if you look at the bottom part, which is the command window, I'm going to copy the code and I'm going to show you the result. So if you type that, you can see 1, 2, 3 is simply the first row, and the 2, 3, 4 is the second row. And the way to make it into a row is the semicolon. So you can also make it to be like a 1, 2, 3, 2, 3, 4. If you do that, you simply just change this one by after the 2, you put a semicolon, and this one should be a comma, and the next one will be the semicolon. So in this way, then you change the matrix. Still, the element is the same, but you change how they format it, right? You have 3 by 2 matrix by using this way. Okay, the next part here is that sometimes you just need some subset of the matrix. Then how do you get those subset? And it depends on what kind of subset that you want. So you can do a subset in several different ways. Here I give you some example. The first one here is that when you wanted to get a subset, you don't put square bracket, no. When you wanted to get the element, you use the parenthesis. The parenthesis, whatever in the parenthesis is the location of the object in the matrix. So this parenthesis is what we call the indexing. The indexing symbol will have several numbers in there. Sometimes they only have one number, sometimes they have two numbers, and they could have three numbers. So the number represents that you are looking at the index in one dimension or two dimension or even more dimension. Okay, so you probably can guess if I put like A, the parenthesis 1, 2, what that means is I wanted to get the element which is at the location 1 and 2. Okay, so that's what this means. The A parenthesis 1, 2, meaning I wanted to get the element in the A and the location is 1, 2. 1, 2, you can think of that as like is like the x and y axis, and I wanted to get the first element in the row and the second element in the column. So the first number represent which row that is. The second number represent which column that is. Now you look at the A here. So at the bottom, I run the A. This is an A. The first row is 1, 2, 3. Second row is 2, 3, 4. So I want first row. The first row will be the first one over here. The second column meaning number 2. So if you run this, you're supposed to get 2. Okay. If I change my A to be in this way, if you change the A in this way, then you can look at this matrix, and then you will know if you look at the same position, you look at the first row and second column, then this number is still going to be 2. Okay, so that's how you do the indexing. The next example here, I put A sub. So A sub meaning you not only get one element out of this matrix. If you want to get a subset of the matrix, so subset meaning you just get a small portion of the original matrix. Now you can do several different ways. I'm just showing one example here. This example that I showing to you, I use several different symbols here. Now, if you look at this column here, when you use a column, the column represent all of them. If you don't have any number before the column and after the column, that column itself represent all. That represent the whole range. So if you put put a column at here, and the first number represent the row, that means all of the rows. Okay, so it's all of the rows. I'm going to get a subset of that. So I need all of the rows. The second one here that I put is the 2. Again, I put the column, but I put n. Okay, what that means is you want the column, which is the second column, all the way to the last column. So this represents from second to the end, second to the end. So if you just use one single column, that represent all. If you use the column with a number, that represent from where to where, and that's what that means. Okay, so let's just run these two. And oh, there's another one, which is this one here. So what happened if your A is a matrix, but you only put one number? Well, this is what we call a single indexing. The single indexing has a certain rule how they number the element in a matrix. If you read the Zeitberg, you will find out. But I will show you and I will tell you what that is. So let me just run this one and show you the result of these things over here. So let me just run this one here. Okay, so if I go back, you can see this is an A. This is how I started. I create a 2 by 3. Then I put 1, 2, which is this one, number 10, line number 10. It picked the number, which is the first row, second column. This is the number that you pick out. Then you do a sub. So the sub is all rows, but column is from 2 to the end, where n is 3. So this is the original. I want all rows, so all rows, but column from 2 to 3, right? This one here and this one here. That's why you got this subset over here. If you want to get the first two, let's say these two, this one and this one, then how do you write that? Well, if you want to get this small subset, and do you include all rows? Yes, so you're going to put the you're going to put a colon here as well. But you are starting from the first one to the second one. So instead of a 2 to the end, you will put 1 colon and 2. Then you will get these 4 elements. Okay, so that's the one. Now, the last one is the single indexing. The single indexing give you 3. So let's look at what is 3. Where is the 3? I have 2, 3 over here. 1 at here, 1 at here. Now, the way the single indexing is, you make this matrix to be like a single, like a rows. But when you make it into a single rows, you need to flatten this matrix. The way they flatten the matrix is they go in this direction. So they have the number, they will go this one to be the 1, 2, 3, 4, 5, 6. So when you flatten it, it will go in this order. If you have more element at here, then you will go down, then you go back, and then go down. So it's going the same column, then jump to the same column, then jump to the next column, then next column, etc., etc. And therefore, when you do the number 4, you're doing the 1, 2, 3, 4, and this is the number 4. If you wanted to get this one here, you will put 5. If you want to get this one here, you're going to put 2. That's how the single indexing is. So that is the single index. All right, so now after this, I just want to give you some like a useful command related to how big the matrix is. So in an array, we have a command called length. So the length gives you the length of the element, right? So it makes sense that if you only have an array, this could be a row array. It could be a column array. Column array is go vertical. Row array go horizontal. Then you can use length to find out how many elements in an array. If you have a matrix, then you need like at least like 2 output. If this is 2 dimension, you need n by m, right? So you can use this command here called size. When you do size, they will give you 2 numbers. So you can use these 2 numbers to do a lot of things. This is very useful when we are going to talk about loop in the after the first exam. So this is a very useful command. The length is also a very useful command because you need to know how many elements inside of that matrix. Okay. Okay. So that's the first part of this chapter. Let me go to one of the question in your challenge activity, which is 7.2.1. All right. Let me go back to the Zybook. And we're looking at 7.2.1. Okay. All right. This is the problem that you have to solve for this activity. Now, they give you a 2-dimensional array, okay? And they wanted you to find out what is the middle element, find a center element of a square array. Okay, a square array. Square array meaning you have the same number of the row and the number of the column. Okay, either like a 3 by 3, 4 by 4, 5 by 5. All right, so that is the 2D square array. Now, this problem, they wanted to just find the single center element. So they say the n by n can only be an odd number, because if you have even number, then like a 4 by 4, then you don't have like 2.5, right? So there's no 2.5 element in between the 2 and 3. So therefore, it has to be an odd number. So either like a 3 by 3, 5 by 5, 7 by 7, then you want to find the middle number of that. Let's say you have a matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 3 by 3. The middle number will be 5. Now, how do you write a code to pick out that number? It can be arbitrary matrix, but I wanted to get the middle number. Okay, so the question is that, so they write a function here, which is that you're going to start with this. I hope that you're familiar with function because you're going to have function in the first exam. Just make sure that you know when you write a function, the first keyword has to be show up in your first line of the function, that which is function. After that is the syntax, is the way that you use that function. So this is the output equal to the name of the function, and the parentheses tell you what are the inputs. So on the right hand side is the inputs, on the left hand side are the outputs. They kind of describe what these things are. Now, the input is certainly just any kind of the array, and this has to be an R number array. And once they give you an R number array, then you need to find out where is the middle one, right? So how do you know? How do you know what size of this array is? Well, I just told you you can use a size command, right? So they also give you a hint. You can use size to find out what the size of the input is. This is the input, right? So over here that you probably need to know the dimension of the array. So they just give you the variable name, which is this one here. But this one is the center index, meaning if you have 3 by 3, what will be the center? Well, the 3 by 3, the center will be number 2 because you're going to have 3 rows and 3 columns. So it's going to be on the row 2 and column 2. How do you get 2 if you have 3 by 3? Well, then you have to use the size. So meaning that you might need to do a size first. So when you do this, then you can say, oh, I have an n by n. And actually, it will be the n by n because it's a square matrix. So it will be size of what? Of your input array. So this is your input array. So you're going to put this one over here. This one give you the size. But once you get a size, in this example, if that's 3 by 3, what you are going to get is n equals 3. But how do you manipulate that so you will get 2? If you give them with 3 by 3, you can get 2. How do we find the center one? How do we find, like from the 3, how do you get 2? If you got 5, how do you get 3? That is the key part of this. Okay, so now you can think about this. So if you have, let's say you got an n, right? If you divide n by 2, what do you have? If that's 3, you divide by 2, you got 1.5. But 1.5 is, you can, oh, by the way, the index, you can only use integer. You cannot use the floating number. There's no like an element like 1.2 or 1.7. There's no such a position that will give you an element. It has to be integer. So 1.5 is not possible, right? How do you make 1.5 to be 2? Well, you might say, oh, I can add 0.5, right? That's one way that you can just, divide that number by 2 and you add another 0.5. That will give you an integer. But there must be something else that you can do, right? Yeah, so you can use the round functions. And there's several different round functions. Remember, there's a ceiling, there's a floor, there's a fix. Think about which one that you're going to use, and you can solve this one here. Okay, so that's my hint for you on this one here. Okay, then the next thing we're going to talk about is concatenation. So concatenation is that if you have 2 or more array and you want to combine them, how can you do that? Okay, if you have 2 or 3 column and you want to combine it, how do you combine column? How do you combine array? Combine them into a larger one. Okay, or even you can even combine matrix with matrix. So there's several different ways. They have in the MATLAB, they have a command that you can do. If you roll down here, they will see they will show you. Well, there is a command called the CAT, which is a abbreviation for the concatenation, right? And you can also use another set of command called the vert cat and horizontal cat. So cat has three, at least like 3 elements that you can put in there. The first input is that whether you wanted to do a vertical or horizontal. So 1 represent a vertical and 2 represent horizontal. And or you can simply just use the vert cat or horizontal cat. I think this is more easier because sometimes I get confused about, what is the 1 represent. I don't even remember what the 1 is. So maybe this is a better way that you can use these 2 codes. But there's some other simple one that you can do as well. I'm going to show you with the example in the MATLAB right now. Okay, over here, I wrote a simple code over here and just simply tell you what are the way that you can combine matrix or array. Well, you can either use this any one of this command here, the cat or vert cat. You can also use the cat2 or the horizontal cat, cat. So these 2 are the same and these 2 are the same. So, but what does that really mean? Let's just run this and to see the difference. So I'm using these two array. I have a 1, 2, 3 and 8, 9, 7, and I wanted to run these 2 command to see what the 1 and 2 will make difference. Okay, so this first one is the result of 1. The second one is the result of 2. So this first one actually is giving you you concatenate like an array in a like a row and row and row, and but if you do the 2, they will put the second array just right at the end of the first array. So it's like a row going horizontally. That's why the second is also can be replaced by the horse cat. Okay, the horse cat also give you a single row by putting the second row after the first row. So that's the difference of these 2. I have another way you can do the similar thing. And this similar thing is that it's even simpler than the. You can also do that by using the symbol, the comma and the semicolon. So here is the way to do it. If you put A semicolon B, that represents the second one will be jumped to the second line, right? Second row, which will be this one here. And if you use the comma, that will be simply represent the next element is going to be the element of B, but the element of B actually had 3 elements in there. So these 2 doing the same thing as your cat command or vert cat or horse cat. These are all going to be the same. So you can use A, and this will be the semicolon here. Here, this one will be A and comma B. Okay, I forgot the B here. So all these 3 are the same. Okay, So that's the this part over here. Now, if you have a matrix and matrix, when you want to combine them, you have to be careful because the size has to be the same. For example, let's say I have a matrix A, which is 1, 2, 3, and 4. So this is my matrix of A. I have a matrix of B. Now, matrix of B is 2, 3, 4, 4, 5, 6. Okay. And you can see the size of these two are different, right? So if you want to combine it, well, use the simplest way. I can write, say, A semicolon of B, and I wanted to combine them vertically. But you're going to see this is going to give you an error because their size is different. Because the first one has only 2 columns, now the second one has 3 columns. So when you want to combine these two by putting the B at the bottom of the A, then A only have 2 by 2, but this one is 2 by 3. The size doesn't fit. But if you do A comma B, it will work. Right? Because you just simply put the second matrix to be the end of the first matrix. So because they all have the same number of rows, I just adding more columns. Then this will work. Okay, so that's how you can combine a matrix or an array in the MATLAB. Okay, so that's the second part of this chapter. Let me share the Zybook again, and we will look at what is the next topic. Okay, let's look at the next topic. The next topic for the next several sections is going to talk about indexing. Okay, now to do the indexing, you have several different ways. That we just saw one way of doing the indexing is that you simply just use a number. You can also use the indexing similar to the 1D array. If you remember when we do 1D array, we use a logical. We use a logical with a logical meaning true and false, right? If you have true, that number is 1, but it's not number 1, it actually represents as true. Then 0 represents false. And if you want to pick the number that is true, then you can use the logical array to help you to pick the number out. You can also use the integer to represent the number that you want to pick out. Okay, so how do you use a number as the indexing? Well, let me just give you some example, and I'm going to cover several different sections in the following example. So I'm going to talk about how you use the integer to do the indexing. And the next one is that how about that you wanted to index, rows and columns. Okay, you not only look at the one elements. What about you wanted to index in the whole rows, whole column, or from several column from one column to another column, right? The several columns. How do you do that? So I'm going to cover all these things in the next example here. All right, let me just jump through here. Let me just go back to the MATLAB and show you how we are going to show you the difference of these things. Okay, over here, I wrote another code. I just want to show you how you can use the indexing in the MATLAB. Now, I start with this command called n equal to magic 5. Well, magic is a command in the MATLAB. It will create a square matrix. So you can type this. Let me just start with the simple one. Instead of doing 5, let me do 3. You're going to see a matrix, right? So this is a matrix. And when you put 3, meaning it's 3 by 3. If you put 5, it's going to be 5 by 5. Okay, you can put 4 by 4. Now, what this matrix is, if you look at this matrix has a property is the horizontal row, if you sum all the elements, is equal to a number which will be the same as the vertical column. If you sum all the number in the diagonal, is also going to be the same. And in this case, it's 15. So it doesn't matter where you count it, it's going to be 15. This is what we call the magic matrix. Okay, if you do 5, it will be the same thing as well. Well, the total is not going to be the same. And the number to compose this matrix is going to be the total number in the element. So in this case, 3 by 3, you only have 1 to 9, and you can see they never repeat here. So it's, you arrange 1 to 9, and it will always give you this matrix. I start with 5. I just wanted to show you more things here. Now, if I have a 5 by 5 and look at here, the first line that I wrote in here is the n of 2, 4. What does that mean? Well, that means you want the one element, the element is at a location of 2 and 4. So let me run magic 5 and let's see what number should that be. So this is 5 by 5. And you're looking at m of 2, 4. M of 2 and 4. The 2 represent row, so this is a second row. And you look at the fourth column, so the fourth column is this column here, so you are looking at this number. So when you run this code, this A here should be equal to 14. Okay, let's just test it. So if I do here, that is 14, right? If you understand this, then let's look at the B. Now the B, I'm not putting just single number, I put 1 and column 2. And remember, column represent from where to where. If you have number before and after, that means from where to where. If you don't put any number, that represent all of them. So I have the first row and second row, and I'm looking at the number 4 column. First row, the second row are here. Fourth column is 8 and 14. So if you run this, it should give you 8 and 14. Okay, try to think about this. In the MATLAB. Okay, let's look at the third one. I put 2, meaning row 2, 3, n. What does that mean? Well, from column 3 to the last column, the n represents the last column. Here is my matrix. I'm looking at the second row, which is this one here, from the third one to the end. So there should be 7, 14, and 16. Okay. Now, the number 4 is D. D represent only one single column. And I hope you remember the single column meaning all of them, meaning all rows. But I only look at the first column. So it will give you this one here. It will give you the first column over here. Right. So E represents from some row to row 1 to row 2, right? Row 1 to row 2. Now column is from 3 to 5. 3 to 5 is from here to here. So you're getting a subset of these. So you are going to get a subset of this one here. Not including 23 and 5, but this one here. You can also specify one single number. Again, one single number represents single indexing. Single indexing meaning you have to count a number, and this is a tens number. And remember how they count? They count vertically, then go to the next column, and then next column. I'm looking at the number 10. The number 10 will be, this is a 5, 6, 7, 8, 9, 10. So it should be 18. Okay, so that represents 18. All right, then there's a special way to flatten the array. So if you have a matrix, if you just simply put one column Okay, one column, now two column, one column, then you flatten the whole matrix into an array. Okay, so this will make it into an array. You can also delete certain array, certain like a row or certain column. And the way is that you specify all and you make it into this one here. This is called the empty. Empty. Okay, put two bracket without anything in there. That's empty. This one empty the second row. This one empty what? The last column. Okay, the first one represent all rows, right? All of the rows, but the last n represent the last one. So you will empty this one here. Okay. You can also use the logical index to be the index. So what is a logical? Well, the logical is that you use the greater or greater equal, less or less equal, and that will give you a logical array. And that array, it could be a logical matrix as well. That will give you 1 and 0, and 1 represent true and false represent 0. And when you use that as your indexing, then when you get the value out of that, you are going to get a value only satisfied with your condition. And in this case, I just give the condition, which is, can you tell me where the value is greater than 15? What is the value which is greater than 15? Okay, so if you look at here, well, because this matrix is composed by 1 to 25. So when I write this one, it simply say I wanted to get the value which is starting from 16 to 25. And that's what this is going to do. Now you could have other kind of application because when the matrix M here is not like a magic. This matrix could be like a score of the students, and then you might want to say, oh, I wanted the score of the student who has a higher than 65, for example, and then you can do that using this way to do the indexing. Okay, so that's let's do another thing which I didn't put in here. Let's say I have an n over here. Okay, so you can see n is here. Now, I want to pick the value out of this matrix, but I want to pick like a randomly. Let's say, well, it's not randomly. I'm going to specify what I wanted to get. So let's say I want to get this one here. I also want to get this one here. I also want to get this one here. Okay, now these three elements, but when you want to say you want to get these, you need to know what the location is, right? So here I have a location. This one here is the first row, second column. The second element is the row of 3 and column is 3. This one here is row of 2 and column. You can use the indexing, but when you do the indexing, you don't put single number, you put all these 3 numbers. So you put a square over here to specify your location of the element. The first location is the first number location, which is the location of the row. I have the first row, I have the third row, I have the second row. And what about column? I want the second column, the third column, and fifth column. Oh, no, I didn't get that. Okay, I guess this is not right. What is my original one? Okay, this is 24. So what do I get here? Wrong. So I want to get 24. I want to get 13. I don't want to get 16, right? I got 24, 13, and 16, but I also got the rest of things show up. Okay. I guess this is not the correct way of generating that. There are several different ways you can get only those value. Certainly you can specify each one of them if you wanted to. Then you can say, I put the bracket here, but I specify each pair of the dimension, which will be 1 and 2, like this one. And then you put an n, which is the second pair will be 3 by 3. And you put the third one, that will be 2 by 5. I guess the first way that I did is not right. You cannot use that way to get those values. But the second way will certainly work because I simply specify 3 different elements from the first array, from the first original matrix. Okay.
The first one is the row. The second one is the column. Yeah.
Yeah, the first number is the row, yeah. And the second one is the column. So if you see 1 and 2 will be the first row and second column, so it's 24 here. That's why you got 24 here.
Okay.
Yeah. All right, so so that's how you do an indexing. You're gonna see more in the book. Let's see, I have anything I wanted to talk about here. There's some of the challenging problem I wanted to tell you. Let me go back to the Xi book, which is not easy. And I want to give you some hint. Otherwise, it will be hard. It's really, some of them are not easy, really. 7 point, let's see, which one? Seven point 5.2, 7.5. Oh, this is the one. Okay. Okay, so this one is you want to update the price table using a single column. So what is the price table? This is a price table here. And if you look at the price table, so it could be like a price for several different things with a different size, right? So the first row could be like, oh, the price for the burger. The second will be the price for the fries. And then you have the big size, you have mid size and small size, and you will have a different price. And so you can create a table like that. Now, but you're gonna write a code, you're gonna do the change price. Maybe you are on sale for certain things, or and this change price is a column, right? This is an, because you use semicolon, that means this is actually -1 and next line is -1.5. And they say, let's write a code. And it depends on the day. I wanted to change the price maybe on different size. The first day I wanted to change the size on the first one. And maybe the next day I'm going to change the price on the second column. And you can specify the column, which is the column number is 1 or 2. Okay, when you specify 1, that means the element on the first column will be deducted by this price over here. And that's what the code is going to do. And you look at the code, it gives you this function and say, you have 3 input: original price table, which is this one here. This is just an example. Change price is going to be a column like this. And the third one is which column you wanted to change. Okay, are you going to change the first column or second column or third column? And when you write this code, and they give you some hint here. So they say, you're going to start with a new price table. Well, the new price table actually is the result, right? But how do you generate new price table? It's not going to be 0, 0, 0. Well, you have to use some of the things from the input. So how do you change that? Okay, now it tells you, first thing you do is assign a new price table with the data from the price table. Okay, so your price table is what? The new price table is the original price table. So you can simply make this one here to be the same thing as your original price table. Okay, so look at their comments and they're going to help you to finish the code. Now, why do they want to do that? Well, because you don't want to make any changes on the original one, because once you start to change it, then all these will be changed. And you wanted to make a copy of that, and you're going to replace some of the things. And you look at the second comment, they're going to give you another hint how to do the second part.
I'm sorry, I have a question. If I change the table, I can't get the old value, I lost it or something like that?
Yeah, if you change it and you lost it and you cannot never get it back to get the original one. Yeah, the original will be changed.
Okay.
Okay, so there is a reason, because over here you will use the original again over here, and then you don't want it to lose the original one. So how do you change over here? So let's say assign the new price table column is specified by the column's number with the original price data updated by the change price. Wow. It sounds a lot of things here. So you have a new price table, right? This is a new price table. Well, it's actually the same as the old one, but you only change some of them. And what is the thing that you're going to change? So you can specify over here to say which one that you wanted to change. And what is the change? What is the thing you're going to change? It's specified by the column number, right? So if that is the column 1, how do you specify column 1? You specify column 1 by saying, I want all rows, but I want column 1. If you want a column 2, you put all rows, but a column 2. That's how you specify which column that is. Okay, so what you should put in here is actually this one here, the column number here. And that just simply say, I only change this part. I don't touch the rest of the data. I don't touch the rest of data. I only wanted to change this part. But what are you going to change over here? You are going to take the same column from the original price, and you're going to add with this one here. Okay, how do you get the column from this one here? Well, it's going to be the same as this one here. So whatever you write in here, you make a copy to here, but you're not using the new, you're going to use the origin price, and you wanted to get the same column. Okay, over here you should type the column number, and you're going to change it, right? How much are you going to change? Well, you're going to change it by this much, the change price. So you're gonna add this one with the change price. And that's how you solve this problem. I pretty much tell you what the answer is. I didn't type it, but you can figure it out. Okay, any question about this one here? All right, so let me look at another. Yes.
I didn't understand what is the double dot that mean. So you didn't put any value for the column. How are you gonna know it's the first column for the second or the third?
Okay, this means all. So this only, if you only put a column for a matrix, that represent all of them. So if I can go back to the MATLAB and show you what that is. So in the MATLAB, let's say I have an M, right? This is my matrix. I have an M matrix over here. If I only want the second column, which is 24 to 18, how do you get that? You can type an M, you put semicolon meaning all the rows, and I want it to second column. So the
The one I
first,
want to change.
what?
This is the one I want to change, yeah?
You want to change what?
This is the number I want to change it. The price I want to change.
Yeah, so okay, so let's say this is the original price. Okay, so this is the example of original price, which is a 5 by 5. And I wanted to change the second column, which is 24, 5, and 6, and this one here. I want to change them to different number. How do you specify this row over here? You specify by using this way. So this first semicolon, the first column meaning all of the row from the first row to the last row here. The second number represent the number of the column, and this is the column 2.
Oh, okay, I got it now. Yeah.
Okay. And let's say so how do you change it? Now I can simply type the number. I say, okay, 23, 1, and 3, 2, 1. Let's say this is the one I'm going to change. You're going to see the second row is going to change to the new number, but the rest of them are not going to change. Right? I only changed the second column. It was 24, now it's changed to 23, but the 1 still 1, A still A. I only want to change all the rows and the second element on each row, which simply just say second column.
Yeah, I got it. Yeah. Thank you.
Okay. All right. So that is this problem over here. Now the next problem I want to discuss with you, this one, is the 7.9.9. Let me jump to that. Okay, the 7.9 talk about a keyword called AND, and I already told you the AND represents the last line. So you don't need to know what line that is, but when you put the AND, meaning is the last one. Okay, so this problem is called not a swap, this one here. This one is the hardest one. Okay, so this one here, interleave. The example shows you is here. And sometimes it's really hard to understand by looking at the description. It's easier to understand by looking at the example. So this is an example. You have an array called A, you have an array called B. And you wanted to write a function to make the B element to be in between the element of A. So 1, 2, 3, 4, 5, 6. You want to put a 10 in between 1 and 2, put the 20 between 2 and 3, etc., etc. So you can see once you run the code, it's going to generate this. And this is the code that you need to write for this example here. And they don't give you any of the hint. They only give you this. So how are you going to approach this problem? Okay, this one is not easy, but let me just give you the hint. The hint is this. If I go back to the MATLAB and then I show you that hint, it will be easier. Let me go back to the MATLAB. Let's say you have an array A and it's 1 and 2 and 3. I have an array called B, and it's a 0, 0, and 0. I want to put the 0, well, I want to put the 0 after each one of the element of the A. So I want to create 1, 0, 2, 0, 3, 0. The easiest way to do that is this. You can combine these two together into a matrix. How do you combine these two into a matrix? Use the semicolon. Semicolon meaning the second array will be the second line of my matrix, right? So I got a new matrix, but it doesn't help me, right? I don't want this. I want something which is like a 1, 0, 2, 0, 3, 0. But there is a way you can make a matrix into an array, which is using the column. Okay, so I'm going to change the A a little bit. And the way that I'm going to change the A, the C is, I'm going to change the C to be C of column. Let me use D. So it's not going to change what the original one is. So I'll create a new matrix, which is a D, but it's a C parenthesis of column. So if you only use one column and nothing else, that means make any matrix to be flattened. And that's flattened. So you see how they arrange this? They arrange this by each column. They go from vertical and jump to the second column, jump to the second column, the next column. So 1, 0, 2, 0, 3, 0. Isn't that what I wanted to? But it's not quite right because it's a vertical one, but I want a horizontal one. So there's another symbol to make it go to horizontal, which is apostrophe. So if you put an apostrophe, that means you are going to make the row into a column, make the column into a row. It's what we call the transpose. Okay, in the matrix, it's called the transpose. So when you do this, then you got this one here. Okay, now this is very close to what you need to do for that problem, but it's not exactly the same. The second challenge in that problem is they give you two matrices which is not the same size. They give you this one. They give you similar to this one. Okay, these two are not the same size. How do you do this one that is not same size? Well, then you have to do this one in several different steps. The first step is that you can take a subset of the A. So A original have 5, right? But the B only have 3. So this one is longer than the B, and because this is a longer, and then you're gonna left with some elements you don't combine them together. So you can use a way to find how many of the element in the array, and that is you can use the command called length. So you can use the length to find out what is the total number that you have, and that will be the same number, which will be the minimum number of that. Okay, And so let me just write a simple code over here. Okay, so if you look at the code here, I have a length command called, the length command is simply to count how many elements that I have. I have two of them because I wanted to get the length of A, I wanted to get length of B, but I only want to know what is the minimum number of the elements in these two. So in this case, this one is going to give me length of 5, this is going to give me length of 3, the minimum is going to be 3. Oops. Oh, I missed something. Okay, yeah, so the minimum number should be equal to 3, right? So that give you, like, okay, they give you what? They give you, when you want to combine A and B, you don't combine the whole A with B, you only combine the first 3 with B. So when you want to combine them, you want to combine part of A with B. How do you specify part of A with B? You specify A from the first one to the minimum of that, to the minimum of this. Okay. And then what do? You also need to combine B, right? But in general, sometimes A could be longer, sometimes B could be longer. So you can copy the same code, but over here, you're going to write the B, because B could also be longer. And if you do that, and then this will guarantee that your C is always going to be, oh, I need a space. This C will always going to be needed to combine 1, 2, 3, B of 1, 2, 3. What happened to this? It doesn't, it's not right. This is not what I wanted to do. I want the first one was A. Is this one here, E to the minimum of that. B, which is this one here. 1 to the minimum of that. Okay. And I need a bracket at the end. There's so many brackets. I think I messed up with the bracket. Let me make sure the first one is correct, then I'll fix the second one. Let me just wanted to. Then some A, then some B, the minimum of that, which is this one here. This represents from 1 to the end of that. This one represents that. Okay, so this one is correct. So what I was doing is, I know my A is from 1 to 5. Now, because B only have 3, And when I take the minimum number of the elements, it should give me just 3 because B is shorter. So I just wanted to get the first 3 from the A. Now I should also get the first 3 from the B as well. And I need to put it on to the second row. So I need 0, 0, 0 behind this one. And then the way to make this happen is you can copy things inside of this. And you put a semicolon, and here you copy the A, but you change this A to B. Okay, so then this is correct. So I hope that you understand what I'm saying here, because you wanted to flatten it and you transport it such that you can put the B elements in between the A elements, but they only work when they are the same number of the rows, same number of the columns. So I have to use this way to make it the same number. But this is, again, this is not the end of the code. The last part of the missing part is because they are not the same length, right? If they are not same length, that means you have something left over that you have to put them back.
Okay, what about the last two variable in the A array? They will delete this variable, or because
Yeah, so that's the last part I want to tell you. So if you do this part here, you got this one here, and then you can say, okay, I got a D, right? And D is equal to my C, and flatten it. Then I put a comma, put an apostrophe to make it into a row, right? Now I got 1, 0, 2, 0, 3, 0, but I also need 5 and 6, 4 and 5, right? So what is 4 and 5? Well, the 4 and 5 is going to be whatever the left over from A, right? So you can say, okay, my last one is actually going to be equal to D, and I need to concatenate with the rest of the element in the A. So what are the rest of element in the A? So we know the minimum number is 3, right? This minimum number is always going to be something that you can use. So I will probably suggest when you do this one here, you can create a variable, say this is a minimum. Create a minimum index, and this minimum index is going to be this one here. So you can save some of the typing because you're going to use this over and over again. So you create a variable just simply to find the minimum of that. And then and what you need to do for the D for the rest of the thing is that you need to get a D, but you also need to concatenate the rest of A, and which will be from A of the, not the last one, because if you use the minimum, it will be the third one, but I want it to be the minimum plus 1, right? I want this one to be minimum index plus 1 to the end. To the end. I don't know what the end is. It depends on the problem, and it might change. So you make that to be the end. And also, not only that, you also need to get the B, because you don't know which one is longer. So you can copy this and make it into the B as well. Okay, so it depends on which one is longer, then it will add the rest of the thing. This one is not easy, but I hope this hint will help you to solve this problem. Otherwise, you probably spend an hour just try to think about way how to solve this problem. All right, if not, if you still have question about this problem here, then you can rewind the video and look at how I solve this. Again, you might want to do this one first to set a variable to store what is the minimum. So otherwise you're going to type a very long line at here. This really saves a lot of time by typing these things, and it's easier, very easy to be messed up with the different symbol, the parentheses, the bracket, there has to be in pair, all right? Now the parentheses and the square represent different things. You have to understand what that means in this code. If you get
Yeah, I
stuck,
need we need to practice for this one. Just try different value, so you can understand it clearly. Because
yeah, you always you always yeah, and I think try error is the best way to learn this actually. Okay, so what I wanted to say is if you got stuck and you have question, you don't know how to solve it, and then you can send me an email or just use a pronto, and then I can give you the hint how to solve that. And that is today's lecture. Okay, any questions?